So we're going to go over how to solve systems of equations that are multiple choice questions in this video. If I gave you a question like this, I usually ask you guys to do all the steps. We had so much work that went behind a problem like this. But today we're going to get another method. Today what I want to talk about is introduction. We're just going to review system of equations very quickly. Okay, a system of equations is a set of two or more equations that we consider to both be true at the same time. So if I look at these two equations that I have two numbers, x and y, and if I add them, I get 10. And if I take x and subtract y from it, I get 6. So what would be the two numbers that make both of these true? In fact, what would be the solution to this system then, we could also call it? Well, would it be 0, 0? Well, we could check. Is 0 plus 0 equal to 10? So don't forget again that this is the x coordinate and that's our y coordinate. Well, 0 plus 0 is definitely not equal to 10. So I know in this case that can't be. That's not true. That can't be the idea. So what I would do now is I could eliminate a, because a does not make this equation true. Okay, and to find a solution, let's go down here and see a little bit, okay? For a system of two equations with two variables like x and y, like how we have here, a solution is often represented as an ordered pair. Okay, and so that's where we got two numbers in parentheses like this. They separate with a comma, and the first one is x, and the second one is always y. So we're assuming that you understand that process, that we're in this order. Okay, first is x and second is y. Now the solution of a system of equations is the set of numbers that makes all of the equations true. So we want numbers x and y that make all of these equations true. So not just the one on top and not the one on bottom, but both of them. Okay, well, we can see that it's not 0 and 0. Okay, because 0 plus 0 does not make 10. What if we look at the next one? What if we go look at 2 and 3? Okay, can 2 and 3 be a solution to this system? Well, 2 plus 3 is 5. It's not 10. So B can also not be a solution. So both A and B have been thrown out. We can eliminate those two. That can't possibly be the answer. Okay, so now let's go try 6 and 4. Okay, 6 plus 4 does make 10. So we would say that this answer satisfies the first equation, right? This solution does satisfy this one. But what about the next one, okay? Is 6 minus 4 equal to 6? No, that's not true. 6 minus 4 is equal to 2, not 6. So these numbers, even though they make the first equation true, they don't make all of the equations true. They only make the first one true, not the second. Let's try option D. Let's go see how this one works. Well, 8 plus 2 does make 10. But now if we look here, 8 minus 2, because 2 is the y, that does make 6. And so we can see that this is the answer. Okay, the answer is D. And so that tells us that we can actually use our definition of the solution of a system to help us understand how to solve these multiple choice problems. In other words, you guys should be able to plug in your numbers and see if they actually satisfy the equations. And that means if you have enough time to double check that, you should be able to answer all of these systems problems. So again, you should definitely copy this down into your notes, because this is a big idea that you want to have on the final day. The solution of a system of equations is the set of numbers that makes all of the equations true. Okay, and in this case, the set of numbers is just a set of two numbers, an ordered pair x and y. Let's go look at some examples now. Okay, before we look at this example, I actually think it can be simpler to look at maybe an example that doesn't have slope-intercept form. And then what I'm going to do is try to get us some values that are mainly positive to have our first example make a little bit more sense. So I'll generate a few and we'll stick with this one. Okay, so I'd like you to test, using the method that I just showed you, how do we find the solution of this system of equations? So I'm just going to start off naively with the first one. We're going to examine A. Let's check A. Well, again, don't forget, there's my x value and my y value. Okay, so I'm going to go plug those in here and see if they make this first equation true. I'm going to go see when I plug in my value for x and y, does it really make negative 13? What does it make? Okay, so we'll go take a look at this. Well, if I plug in my negative 3 here, because that's my x value, right? That's x, okay? And if I plug in my y value is 4, if I plug that there, again, x for x and y for y. Okay, is this true? Does this make a true fact? Well, we could think about that. What is 2 times negative 3? That makes negative 6. And 4 times 5 is 20. So what is negative 6 plus 20? This makes 14, positive 14. This does not make negative 13. And so what I would do is cross this out. And I would say, hey, this doesn't make the first equation true. And now I can try the next one. So that means that actually quite a lot of this can be done without writing. Without writing the whole equation especially. Okay, you guys can save time and make sure that you know how to chip away at this process. So we'll just do the next one. Okay, we'll try B. And every now and then you might see the big picture and notice that one of them has to be the right one. So right now we could go ahead and go plug in 2 times negative 4 plus 5 times negative 3. And we'll see what that makes. Okay, well, when I do that, I get negative 8. And then 5 times negative 3 is negative 15. So this makes negative 8 plus negative 15. I'll go ahead and write both simples there. We might as well. It's finals. Well, that's the same thing as negative 8 minus 15. And that means that this is going to be minus 23. And that's definitely not equal to what we needed over here that was minus 13. So that means C cannot be the answer either. So now it's got to be either B or D. And we've successfully brought it down to a 50-50. And notice that it wasn't really that much work. It was just a little bit of calculation, not a lot of writing. So we'll start with B and just see what happens. We'll plug in 4 for x, and we'll plug in negative 3 for y. And don't forget that x is getting plugged in for x, right? And y is getting plugged in for y, so just don't mess that up. Any kind of way the equation looks, that's how you do it. So we have 8. 5 times negative 3 is negative 15. So we got 8 minus 15. And that's going to give us negative 7. And negative 7 is definitely not equal to negative 13, so that means I could cross out this one too. And that leaves me only with option D. So we'll do that one just to verify, and then we'll double check both of them. But when you're running out of time on the test, you have to make a selection. So sometimes if you could at least bring it down to a 50-50, you can take that home and at least hope that you were right. So now I plugged in my x and my y values, and now we'll just see if it's right. Well, 2 times 1 is 2. And so then I write plus, and now 5 times negative 3 means minus 15. So 2 plus negative 15, well, that's just 2 minus 15. But that is exactly equal to negative 13. And so that means that this number for D, it made the first one true. So now we'll have to check the next one. So we could go see if it makes the next equation true. Let's see if it makes the blue equation true. Okay, I want to emphasize that we already eliminated all the other possibilities. So we should definitely be able to move on. But because I'm teaching you guys this, I'm going to continue the work, right? But I wouldn't blame any of you guys if you're going to move on already and do something else when you're on a problem like this, okay? The equation is 5x plus 8y, so I'll just put some blank parentheses here. You guys can see a way to save some time while you're doing this. Okay, give yourself the blanks and go put the numbers in there. The 1 goes here, and the negative 3 goes there. Okay, well, 5 times 1 is 5. And then that's plus negative 24, right? Is this equal to negative 19? Well, of course it is, right? Because this is the same thing as 5 minus 24, and that is equal to negative 19, right? If we look at this, we see negative 19 equals negative 19, and so that's true, right? It makes the equation true, and therefore, this is the answer, okay? The solution made both of these true. So you can use some common sense to help you guys get through this and avoid doing all of the substitution work that we taught you guys to do. Okay, I'm not sure you guys really recall how much other work there was. If I showed you the other way to do this, just go watch the video on substitution. If you really miss it, okay, you can go watch that video all you want, and that would be the way that you solve it. So now I kind of like you guys to, let's go back and let's try another one. And this is the one that actually bothers me the most. I think this is the one you guys will have the least success. Alright, funnily enough, this was the easy one, right? Because this is a level 1 systems problem. So I know most of you guys can solve this without any little tricks, okay? But I can't help but show you these things because these are both equal to y, remember. What you were supposed to do is put an equal sign between them. And you can solve this equation the long way, the good old-fashioned way like that, okay? But we can also solve it by process of elimination, where we go plug in these numbers and see which one gives us what we need to get, right? So if I go the long way, yeah, I take away 5x from both sides. Okay, that gives us negative 14 over here. And then on the left side, we'll have 3x minus 23. Okay, if I add 23 to both sides, then we end up getting 3x equals 9. Divide both sides by 3. And then we get x equals positive 3. Which, as you can see right here, there's only two options that have that. So I would be able to cross out b and d right here and then continue doing my work. The point of today, though, was for you guys to learn the shortcut. Like, what happens if I just go plug in those numbers? So like I said, this is x, and that's y. So just plug in x for x and y for y and see if we get an equation that's true. Okay? This old way is still a way you can use. Okay? But because I taught that to you guys already, I don't see a way to keep repeating myself and going in circles, right? So if we went the long way, the very next step would be to go write this on the side, right? Y equals 5x minus 14. And then I tell you guys to take that number and plug it in for x, right? So we got y equals 5 times 3 minus 14. Okay, but that's just 15 minus 14. And that's equal to 1. So we know this means that we have the point x equals 3, y equals 1. Okay? That was a lot of work for some people. To put all that down on the page in the middle of the final and get through that, I would be satisfied if some of you guys could actually plug in the numbers in here and show us at least that you know what a solution of a system is. That it has to be the numbers that make both of these equations true. Okay? So now I'm going to go ahead and show you how that would look, because I know you guys have a few examples like that on your final. So, how do I do this work in that case? We're going to go ahead and use this example, and let's just pretend that we had got lucky and guessed right the first time, okay? Well, how would I represent my work? I'm just going to copy the first equation. I think I could even copy them right next to each other so you guys can see that. Okay. This can be done in your head, but right now I'm trying to show you guys what you should be seeing in your head. So bear with me as you guys try to see the process, okay? X and y. We're going to go put those numbers where they go, okay? Be careful. Don't put the 3 here and the 1 there. That's not true. Okay, look again. What does y say? Y is 1. So that means I put the 1 here, and this is going to be 8 times x. And what's x? X is 3. X is this 3 right here. Get that? Okay, so the 1 went on the other side. If I was going to do this one, check your understanding right now. What number is going to go in there for x? What should we put? Okay, well, hopefully you remember that we're doing 3 for x and y is 1. Again, we're trying to see if these numbers make both of these equations true. So that's why we want to plug them into both of those equations. Let's go see if this is true. And don't forget, our symbol for if it's true is where we have a little question mark on top of the equal sign. Okay, well, is this true? Is it true that 1 is equal to 24 minus 23? Well, wait a minute. Yeah, that's true. And what about over here? Is it true that 1 is equal to 15 minus 14? Yeah, that's true. 1 equals 1. And over here, yeah, 24 minus 23 is 1. So these are both true. So we would be able to select this one if we had got that right. Okay? If I had started with this value, we would have got to the bottom and we would have got things that were false. And so we would have been able to eliminate number 1. Okay, so what I'm going to do right now is try to give you guys some chance to do a multiple choice practice virtually. And what's going to happen is I will keep these problems up here and I'll do a couple more and I'll just kind of reveal the answer to you guys so you can check yourself and see if this makes any sense to you. Get another couple ones. If it takes forever to get positives, I might leave you guys stuck with some negatives. All right, there we go. Finally got one. Okay, so we'll do these three as a review of this process, okay? So pause the video, solve it either way, but if I was you, I'd do it by process of elimination. So plug these numbers in and see if they give us what we need to get. Okay, I'm hoping that you guys paused it and have an answer. If I was to select it, I hope that you selected D, -1, -3. Okay? A way that I want you guys to look at this, and don't ever forget, you guys get to functions, right? Y equals 7x plus 4. This is the same thing as f of x equals 7x plus 4, right? And we taught you guys to understand the difference. When you guys move up in math, you're going to stop calling it x and y so much, and you'll start calling them the x and f of x coordinate, all right? Remember, this is our input, and the other one is our output. And that's kind of what we're doing here, okay? When you have this idea of the y equals that, it's like our input is the x value, and we want to see, do I get -8 as an output when I input that here? And that's really what we're looking for if we're going to solve it, right? So is that what I get? What is 7 times 2, right? 7 times 2 is 14. So if I add 4, we get 14 plus 4. And that gives me 18. So I can see when I input 2 into this function, my output is 18. My output is not that, right? So that means that this one will be incorrect, get it? When I input 2, I don't get the output that I want from this function. Okay, so again, it doesn't make that equation true. There's another way to think about it. So plug in the numbers and see what you get. Again, I'm telling you guys, I'm a little nervous about these ones when it's y equals. So I'm going to do one more of these y equals ones. Okay, let's see if you guys can get the answer. Go ahead, pause the video. Try to find this by process of elimination. All the numbers are positive, so that should help you out a little bit. I'm going to reveal the answer in 3, 2, 1, and there you go. 4, 8 is the answer. So if I plugged in any of these other ones, like 8 and 8, we would not get it. If I input 8 into this function, right, 6 times 8 gives me 48, and 48 minus 16 is not equal to 8, right? It doesn't give me the y coordinate that I want. So you can see if we did it this way, though, it will, right? 4 times 6 is 24. And 24 minus 16 does give me 8. So see, when I input this, I get an output of 8 when I plug it into this equation. And so that works, okay? And it would also make the next one true if we tried that too. All right, let's try the next example. Number 2 is no longer with a slope-intercept form equation. So now use these two, okay? Again, we're checking like the 7 times 3 minus 4 times 5 equal 1. Well, yeah, it does, right? Because that's 21 minus 20, and 21 minus 20 is 1. All right? Now, what about 3 for x? Okay, if I plug a 3 there, minus 4 times 5. Well, what's 4 times 5? 4 times 5 is 20, right? Is 3 minus 20 negative 17? It is. So in this case, we got right on the first try for A. Okay, and if we tried any of these other ones, we know they would not have made the solution correct. Okay, so go ahead and try this one. Let's see if you can check your answer. What is the solution to this system of equations? All right, 3, 2, 1. The answer is C. Okay, now what I want to do is get to the word problems that were driving us crazy for a little bit. And we'll do 3 examples to finish up this video. Okay, I won't work the whole problems through, but I'll give you guys something that you can look at. So let's try to recall how to do these word problems. When you read them, one of the first things you want to do when you're setting up your work is to show me what's X and what's Y. Let's make X the seniors, the number of senior tickets, and we'll make Y the number of child tickets. All right? I'm abbreviating it a little bit, so bear with me. I know I didn't write a whole sentence there. Okay, well, the sentence that I underlined and read is telling me that 5x, right, 5 seniors plus, again, because it says total, I know that that means plus. Okay? Well, 2 child tickets, well, we said child tickets would be Y, so that's plus 2Y is 53. Okay, so check your understanding right now. What I underlined in blue, can you write the equation for that? I'm going to write the equation right now, so pause it if you're going to try to learn on your own. You should have 9x plus 14y equals 137. And now we have this system. So now what I'd like you to do is figure out which one of these combinations, right? Don't forget, against the senior citizen ticket is X and the child ticket is Y. Which one of these A, B, and C, and D, which one of those numbers would make both of these equations true? Okay, we can try to plug in some of these numbers and see what they give us. Okay, for instance, just use any of them. Okay, I'm going to count on you guys to pause the video and do it on your own. And then we'll talk about it right now when I reveal the answer. Okay, the answer in this case is D. Okay, let's eliminate a couple so that we can think about it. Now, if I was to take 6, right, and know that that's my X and this is my Y, okay? So is 5 times 6, again, 5 times 6 is 30, right? And 2 times 6 is 12. So is this equal to 53? Because that's the number we're supposed to get. Well, I get 42. And 42 is not 53. So I know that this set of numbers doesn't make the red equation true. So that can't be right either. So I'll erase that one, okay? But if I go try D, we can see what happens here. What happens if I do 9 times 5? That makes 45, okay? So that's 45 bucks from those tickets. But if I sell the 4 child tickets, then that's 8, right? Because it's 4 times 2 is 8. Well, what's 45 plus 8? Does that make 53? It does, right? This is equal to 53. So now I'm going to go try these numbers with the blue equation, okay? So we'll go ahead and say, okay, well, what's 9 times 9? What if I had 9 times 9? Well, 9 times 9 would give me 81, right? So that's 81. But what's this next one going to be? This would give me 14 times, well, 4. So we got 4 child tickets, right? So what are we going to put now? Sorry, $4 per child ticket. So 14 times 4 is 40 plus 16. That's 56. And so what do I get when I add up 56 plus 81? We get 137. And so you can see that these numbers make both of these equations true. Okay, so maybe the hardest part will be for you guys to decode the sentence and make sure that you can write these equations so that you can easily see the relationship that you need. Okay? You might be able to do this without writing it down, but I really wouldn't recommend it. Okay? You want to write down some kind of notes so you have some work on your paper. And this thing that I wrote in the box right here is pretty much the work that you would need to show. So now let's get another example. We'll do 2 more of those, and then we'll call the video over. Okay, so make a choice on this one. And I'll reveal the answer in 3, 2, 1. You should have A. Okay, so you can think about that. Bring me a question if you have something about that. But I don't want to do the whole problem. I want to give you guys some time to practice. So we'll try this one next. Okay. See if you understand the method that we were learning. Okay, write the 2 equations, plug them in, and see if you can do this quickly without solving the whole system by elimination or substitution or something. 3, 2, 1. There's the answer. It's A this time. Alright, I feel like giving you guys one last time. I feel like there must be at least one of y'all out there that almost got it last time but missed it. So let's try one more time for you guys. Last one for sure. Okay, so again, write the system down and then eliminate as needed until you find the answer. Okay? 3, 2, 1, and the answer is B. Okay, I highly recommend that you guys go back and study everything else, and really do not forget what we were looking at. This slide I'll pull up about the y-intercept is something I talked about for a long time today, because you guys know I mentioned that this is a very important concept on the final exam. We're going to have so many different tests on the y-intercept. So please know that the y-intercept is where a graph crosses the y-axis. The y-intercept is that value that gets associated with the x value of 0. So the y-intercept is right here at 2, right? And we know that for the y-intercept, the x value has to be 0, okay? And we also think about this as the initial value, as the starting value, because think about it, if x value is 0, well, what I told you guys for a while, we've been talking about when you do math with physics, we use the x-axis to be time. And so because time equals 0, right, would have to do with something starting. That's usually what we need. So if you see a word problem that has to do with the y-intercept, a lot of times it will be talking about the initial value or the starting value and whatever it was that we were working with. All right, I wish you guys luck studying for the final. And do not forget to complete your final portfolio.